This video goes over your Module 3 exit ticket. For question 1, we're trying to create an equation and solve an equation to answer our question of how many tickets must be purchased in order for the total cost to be the same on the two carnivals, or at the two carnivals. So we have M equal to P, that's what we want. For Carnival M, they charge an interest fee of $5, so that's our y-intercept because it's a fee. And then our M value, or our slope, is the 65 cents per ticket. So for Carnival M, we're going to create our equation of $5 plus 65 hundredths times x, and we're setting that equal to Carnival P charges a fee of $10, and then 45 cents per ticket after that. So this is our equation. Now we're ready to solve. We're going to start by getting our variables on the same side by subtracting or doing the opposite of the smaller value. When we do that, we get 5 plus 2/10 or 20 hundredths x equals 10. We're then going to subtract this 5 from each side of our equal sign here, canceling on this side, and resulting in 20 hundredths times x is equal to 5. We then divide by 20 hundredths, and when we do, we get our answer of x is equal to 25. Question 2, we're once again writing an equation and solving it. So let's start by reading the problem and then creating our equation. It says the Education Foundation is hosting an online fun run. Lauren and Allie are both participating in this run. Lauren has already run 2 miles and plans to run 10 miles per week. Allie has already run 4 miles and plans to run 5 miles per week. After how many weeks will the two have run the same total distance? So when it says we want them to have the same total distance, that means we want Lauren to be equal to Allie. Now that we've identified our overall structure of this equation, we're going to then focus on each runner individually. So let's start with Lauren. Lauren already ran 2 miles, so that's our constant. And she's running 10 miles per week. That per week's letting us know that's our coefficient. So altogether that would be 10 times x plus 2 for Lauren. We want these two to be equal, so we can go ahead and place that equal sign there. And now we're going to look at Allie. Allie has already run 4 miles, so that's once again our constant. And her plan is to run 5 miles per week, so that's our coefficient. This creates 5 times x, our number of weeks, plus the 4 miles she already ran. Now we're ready to solve. We're going to start by getting our constants on the same side. So I'm going to subtract 2 from both sides, canceling it here. That gives me 10 times x is equal to 5 times x plus 2. Next up, I'm going to get my variables on the same side. So I'm going to subtract 5x, subtract 5x. When I do that, it cancels on the right side, and we get 5 times x is equal to 2. Now all we have to do is divide by our coefficient to eliminate it. Those cancel, and we get x is equal to 2/5. So our answer would be 2/5 weeks. For question 3, we're given a model and we're just to write an equation. So on the left side, we have 3 positives here, 3 positive ones. So that's going to translate to just a positive 3. And then we have 1, 2, 3, 4, 5, 6, 7, 8 positive x's. So we're going to put 3 plus 8x is equal to, on the right side, we have 6 negative ones. So that's going to become -6. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 negative x's. So that's -11x. This model matches answer choice D's equation. Question 4 gives us an equation, and we're helping Ashley solve it by telling her what her first step would be. Our first step is going to be to get our variables on the same side, which would require us to either subtract 400 or subtract 200x from both sides. That means that from our answer choices, this would be the correct answer because it's the only one that gets us started by getting our variables on the same side of the equal sign. For question 5, we're trying to answer the question of how long will it take for Sarah and Marcia to have the same amount of water in their pools. We're going to start by finding the different pieces of information for Sarah and Marcia and then set them equal to each other. Sarah starts with 5 gallons in her pool, so that is her B value, and she's filling it at a rate of 3 gallons per hour. That's her M value. So that means for Sarah, we're going to write 3x plus 5, and that's going to be set equal to Marcia's information. She starts with 7 gallons, so that's our y-intercept, and fills her pool at the same rate as Sarah. So we're going to put 3x plus 7. We're now looking for an equation that has this similar setup. So looking at answer choice A, we have 5 minus 3x. That's not what's happening. We're not draining our pool, we're filling it, so that should be a positive. With answer choice B, we see that the 5 is our rate here, and that is not the case for either Sarah or Marcia. Same goes for answer choice C. 7 is never our rate that they're filling the pool, so we can cross that off. And that leaves us with D as our correct answer. We see the same pieces of information, just in different orders.